I'm hitting record. Thank you. Glad for the reminder. All right, now let me go. So I'm only going to record the lecture stuff, the review stuff. I'll leave. All right. So last time we had talked about counting by weighing a little bit. I did that thing with the paper clips, which I thought was kind of interesting in a, I'm not on a screen share either. Good God, Rob. Where's screen share? It's way down here. Here it is. All right, now we're ready to go. So when we count by weighing, atoms are very small. So this is a very important idea. And this is actually an SI unit. The SI unit for number of particles, like a dozen, you're used to it, like a dozen eggs or a pair of shoes. That's a word that means a number, 1 mole. And this is not on this test. This is the first material for exam 2. And when the next lecture I give will be face-to-face, it'll be on the 28th. Also, don't forget masking, when you're back on campus. Okay, 1 mole is 6.022 times 10 to the 23rd. Just like one dozen is 12. This number is called, let me just move this over and make it bigger. This is called Avogadro's. The symbol is N subscript capital A, and it's called Avogadro's number. Named after Amadeo Avogadro, who determined it experimentally. All right, so that means 1 mole of anything is that many. So one, and again, it's just a word that means a number, right? You're used to 1 pair is this number, 1 dozen is this number. So this word means this number. This word means this number. This word means this number. I would memorize this, again, not for this exam, but you're going to need this. But I would say that by the time you're done doing homework 4, you will have typed it into your calculator so many times that you'll be an expert with it. Right? You probably don't have to actually memorize it like on a flashcard. So now another concept is a molar mass. And that is the mass of 1 mole of substance, of whatever that substance is. Okay, and so the unit is grams per mole. Now molar mass is a general term. I use that term, atomic mass, or remember we use the words mass and weight interchangeably. Atomic mass is the mass of 1 mole of atoms, of an element. And a molecular mass or formula mass also called a formula mass. This is the same thing, but it's for a compound. We'll deal with that in the next lecture. All right. So atomic mass is and atomic mass are these numbers on the periodic table. And I know this is a little bit small. There we go. But you see, for example, for beryllium, it's 9.01. For boron, it's 10.81. Okay, those are molar masses. All right. So let me just do a few things with this. Okay, I'm gonna erase. I'll leave that up there for right now, just so you get used to it. I'm just going to do a little bit of stuff, and I'm going to do 6 problems, and then we'll just go to exam review. Okay. So just remember, so what this means is 1 mole of carbon atoms or carbon is 6. Let me just do this. 1 mole of carbon. Oops. Is 6.022 times 10 to the 23rd carbon atoms. So the unit on Avogadro's number is moles in the denominator. So it's whatever per mole. So atoms per mole. Okay, 1 mole of carbon. And carbon, if you look on the periodic table, the molar mass of carbon is 12.011. Similarly, 1 mole, let's pick another element, 1 mole of tungsten, okay, is 6.022 times 10 to the 23rd tungsten atoms. And if we look up tungsten on the periodic table, it's 183.84. So that's 183, this is carbon, 84. And I'm getting that right off of the periodic table, all right? So I'm gonna do just a handful of problems with this. So how about how many sulfur atoms in 0.046 moles of sulfur, all right? So this is just using your dimensional analysis. We want the unit to be moles of, we want sulfur atoms as our unit, okay? And we're going to start with point, now Avogadro's number has 4 significant figures. It was determined experimentally. And so then we use Avogadro's number. There are 6.022 times 10 to the 23rd sulfur atoms per mole of sulfur. You want to get in the habit, using dimensional analysis, of being descriptive with your units. Don't just write atoms, write sulfur atoms. Don't just write moles, but moles of sulfur. I'm not going to take out points if you don't do that, but you want to start doing that internally, because you'll see as we progress that you might have moles of 3 different things, and you want to keep track of what's what. So this comes out to be 2.77 times 10 to the 22nd. I'm going to erase all this up here. I'm going to replace this with something. So there's a rubric that I'm going to develop for you. And as I said, you know, in addition to these lectures, I did post the stuff I did when I was teaching this class online, you know, and those lectures are available. What this shows is I went from moles to particles. I'm going to be very general. An atom is a type of a particle. And what I did is I used Avogadro's number. Let's leave this up here. Let's do another one. How about how many moles of, how about sodium in 1.185 times 10 to the 19th sodium atoms? Oops. All right. So in this case, we want the unit to be moles of sodium. All right. So always, always, always write down the units of your answer. Very important, right? So then I'm going to start with 1.185 times 10 to the 19th sodium atoms. And then I want atoms in the bottom. I know that 1 mole of sodium is 6.022 times 10 to the 23rd sodium atoms. This is where you want to make sure you can do this on your calculator. If you're using scientific notation wrong, you're going to get something like 10 to the 40th, 10 to the 42. And I don't want to spend time on that today. You can certainly ask me during office hours to help, but it's way easier for me to help you with calculators when we're back in the same room. So this is 4 sig figs, 1.9678, well, make it an 8, sorry, times 10 to the -5th. That says 1.968. All right, so what this problem showed is I went from particles to moles. So I can go from moles to particles or from particles to moles using Avogadro's number. All right. Let's do this one down here. Now let's do a couple with mass. How about how many moles? Well, let's do what is the mass? Let's do mass. Doesn't really matter though. All right, so this says what's the mass of 0.751 moles of lead. So right away, we want the unit to be grams, and the symbol for lead is PB. Again, I'm trying to get used to looking things up. Now, we have, see how what we did with the unit conversion now, we're using it for actual chemistry, moles of lead. So to go from moles to grams, even if you didn't remember that you used the molar mass, you'd say, well, what do I need? I need grams of lead per mole of lead. And hopefully, when you've gotten a little bit practice with this, you'll go, aha, that's the molar mass. And I can always get the molar mass off the periodic table. Lead, I know it's a little small here, but hopefully, again, I think I suggested this, print a periodic table and have it handy for yourself. It's 207.2. And I got that right off the periodic table. And so then we do the math. All right, so this comes out to be 156. So this showed I can go from moles to mass using the molar mass. I see something in the chat. No, Avogadro's number has 4 sig figs. There's way more digits than that. These are the ones that I'm giving you. So in this class, it has 4. Good question. And molar mass is a word about sig figs on molar masses. Molar masses, use those as the sig figs because molar masses are determined experimentally. All right. I always say though, carry your molar mass 1 more digit than you're going to need if you can. So, molar masses, some of them have 5 or 6 sig figs. Use this number to drive what you round it to. See how I carried this to 4? All right, I'm going to do 3 more problems, and then, like I said, we can just do some review, or I'll let you guys review. How many moles? So the problem solving here, we've done more complicated problem solving already. We're just adding new things. But if you've gotten good enough with the approach to problem solving, this shouldn't be too bad. How many moles of, how about silver? In 14.2 grams of silver. I'll tell you a really funny story real quick. So this will, if anyone is worried about asking what they perceive as a stupid question, all right, this will make you feel better, all right? And that way you'll always ask the question because there is no such thing as a stupid question unless you don't ask it. The unit, the symbol for silver is Ag, and we want moles of Ag. And what's really funny is about this, a funny story. When I started graduate school, I was my professor's first graduate student. And I came straight out of college, had my degree in chemistry, I minored in biology, and I was working in an immunology lab. And because I was her friend, and actually worked for her the summer before we started because I needed money, I had to pay rent, and my compensation didn't start till school started. And she said, well, you're my first graduate student, so here's my grants, read through them, and we'll pick something that you can work on, which is great. And so I'm reading through the grants. I went over the weekend, and I was so impressed with myself because I actually understood most of it, so I think I'm a genius or something like that. But all over this thing, because this is immunology, all over this thing it says Ag, 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 right? Ag. And so when I went into her office on Monday morning, she said, so what did you think? Do you have any questions? I go, I think I kind of get the general idea, but what are you using all the silver for? I don't quite get all the silver because it says Ag, Ag, right? And she looked at me, she says, AG means antigen. I still think it's funny. And I felt about this big, and I had a good laugh, and so did she. But again, and that's another example. Different things mean different things, have different meanings in different contexts. So I'm sitting there one-on-one with this person, and I go, what's all, and she says, it means antigen. I was like, oh, that explains everything. Anyway, thought I'd throw that out there. So if you think your question is stupid, I got you beat. All right, and I'm trying to make an impression on this person. So we have 14.2 grams of silver. So we want moles, and silver is right here, 107.87, and the unit on a molar mass is grams per mole. So we want moles on the bottom in this case, 107.87 grams of silver. And again, you want to get in the habit of not just writing grams per mole, but grams of Ag per moles of Ag. And the reason you want to get used to doing that, as I said, is when we progress, you might be doing a thing where you have grams of silver and grams of gold in the same problem. And if you don't write which one's which, you'll get confused. This will have 3 sig figs. So this is going to be 0.132. All right, so this just shows I went from mass to moles using the MM here. I'm going to erase that, make it a little bit easier to read. MM here stands for molar mass. So this little rubric we're going to work with a lot as we progress. So the mole is literally the central concept in quantitative chemistry. And they always say, if thou art not in moles, and as Shakespeare said, if thou art not in moles, get thee hence to moles. And if you're not sure what to do to start a problem, and you just make a random guess, maybe I should convert to moles, it's probably not a bad guess. All right. You can go from, so I'm going to do 2 more. I'm going to go from particles to mass, and then I'll go from mass to particles. So what is the mass of 2,361 gold atoms? So this should be a small number, right? Because atoms are very, very, very small. And this is something, this is why the mole concept is considered so powerful, because there's no way I could weigh out that many gold atoms, because gold atoms are too small, right? So we want grams of gold, and we would hope it should be a small number. Gold is AU. I'll move this over. All right. So, so we're going to start with 2,3 gold atoms. Now, again, I could do this in one step if I knew the mass of one atom in grams, but I don't. But I'm in, you could kind of use this as a map. I'm in particles, atoms. I want to go to mass, grams. So I have to go through moles. So the first thing I want to do is I want to get myself to moles. So there's 1 mole of gold for 6.022 times 10 to the 23rd gold atoms. I'm going to cancel out as I go. So that same approach to problem solving that we've been using. Now I'm in moles. I want to go to grams. I look up the molar mass of gold, 196.97. 196.97 grams, and I want grams on the top. Moles cancel. So my answer will have 4 sig figs, 2361 divided by Avogadro's number times 196.97. So I get 7.722 times 10 to the minus 19th. And that makes sense. Atoms are small. All right. And again, this is why the mole concept is so powerful, is that I can determine, there's no way I could weigh that out, but I can figure it out, right? Let's do 1 more. And this is the count by weighing. How many Let's pick an element. How about zinc? In 52.61 grams of zinc. And actually, just to give you a little perspective, when I was doing my graduate work, I was working with proteins. And I was literally trying to make sure I had a certain number of protein molecules in my test tube. And even proteins, which have molar masses in the tens of thousands, are really big molecules, you still can't count them. And so I would literally count them by weighing them. I need this many protein molecules, so I'm going to weigh out this much of this protein. All right, so we want the answer to be zinc atoms. And I'm going to start with 52.61 grams of zinc. Now, the principle of the approach to problem solving of working backwards is something I do a lot as well. So this one I worked forwards. I'm going to just show you how to work this one backwards. So that it's the thought progression. And again, you can go forwards or backwards. It's completely up to you. But if you know how to work forwards and backwards, that's way more powerful, because if you get stuck going one way, work the other way, and perhaps working both ends against the middle. All right. So if I'm working backwards, I'm thinking about units. I need to get the unit atoms, and I can always get atoms from Avogadro's number. I need it on top. So I know that there are 6.022 times 10 to the 23rd zinc atoms per mole of zinc. So now I want a unit that has moles of zinc on the top. I got the right unit in the right place, but I got to get rid of grams, and I need grams of zinc in the bottom. Right? And then, grams and moles, that's the molar mass. If you look up the molar mass of zinc, it's right here, 65.38. The molar mass always goes with the grams. It's always grams for 1 mole. I don't bother to write the 1 because I'm efficient. It's my synonym for lazy. Okay. 52.61 divided by 65.38 times Avogadro's number. So that's going to be 4 significant figures, 4.846. Zinc atoms. All right. So this problem showed if I want to go from mass to particles, I still have to go through moles. So I wanted to make sure we, took some time. I don't feel like I rushed. I wanted to make sure I got these 6 problems in your notes. So just as to review, we did particles to moles, moles to particles, moles to mass, mass to moles, particles to mass, mass to particles. So this is not on this exam, but I've introduced the concept. The next lecture where I go over this material will be a week from Monday, because that's this coming Monday is a holiday. I might back up and do maybe 1 more of these, and then I'll go forward and do more of it on that day. Okay, also I did say we have a person in the class who is requesting a note taker. So at your convenience, let me know. And I can hook you up and we'll get that all squared away. And if no one comes to me, I'll bring it up again in the next lecture. All right, I'm going to turn off the screen share now. A note taker is someone who takes notes and then shares their notes with a person in the class. So I'm going to stop the recording.